Okay, so continue from the previous lesson. We want to determine the dimension of derived quantities. Okay, so the derived quantities we have here, let's say for first example, is velocity. Okay, so I'm just going to redo this part here. Okay, velocity. We want to find the dimension of velocity. Okay, so the velocity, we have to write down the equation to find the velocity, which is the equation is the change of displacement, okay, over time. Okay, just now I show you that the equation for velocity is s over time. So you can either write it like this if you want to, or you can also write it as v equals to, okay, delta. Sorry, there is delta here. Delta s over delta t. Okay, so you have to put the square bracket because we want to find the dimension for the quantity here. So the dimension of v would be equals to the dimension of s is the displacement. So displacement is length, therefore the dimension for length is L. And then the time, delta t is time, so the dimension for time is t. So the answer will be, you have to write it down like this. Okay, so the answer is lt minus 1. So this is the dimension for v, lt minus 1. Moving on to the second one, volume. So you know that volume is, the equation to find volume is V equals to height, length times width times height. So all of this is length actually. Width is also, we also measure it using ruler. So it's also a length. And height also we measure it using ruler. So all of this is length. So we want to find the volume. So this one should be, this one should be V, volume. So this one would be length. So we want to find the dimension of V. So it would be length, the dimension of length times the dimension of length times the dimension of length. So the answer would be, the dimension of length is L times L times L. So it will be L cubed. There you go, we got the answer for the dimension of V is L cubed. Okay, moving on to acceleration. So acceleration is simply the equation to find acceleration is the change of velocity over the change of time. So in order to find the dimension, we have to put the square bracket around the symbol, which is delta V over delta t. So we already solved that the dimension for delta V just now. Okay, the dimension for velocity is Lt minus 1. So we just gonna straight write down it as what we already done in the first part here. Okay, so refer to that. So we got Lt minus 1 over the time is t. So we solve this. This one would be equals to LT minus 2. Okay. So for this one, density, okay, I give you the equation. The equation is density is rho. The symbol is rho. Want to find the dimension of density is equals to the dimension of mass, because the equation to find density is mass over volume. Therefore, we got that mass over volume. Mass, the dimension of mass is equal to the capital M, and the dimension of volume, we already solved it here, which is L cubed. So we got the answer as ml negative 3. Okay, so from the dimension we can also write down the unit. Okay, so L is meter, which is length, T is second. So we can also got the correct unit from the dimension of each quantity that we solve here. So length cube, which is the unit will be meter cube. For this one, LT minus 2 would be meter as negative 2 because T is second. And then we just write down the power. For this one, it would be mass is kg and L is meter, negative 3. The unit for length is meter. So there you go, we get the unit for the density. Okay, so for momentum, the symbol for momentum is P equals to mass times velocity. So because we want to find the dimension, we have to put a square bracket around the quantity. Okay, so you need to solve this on your own. And force is equals to mass time acceleration. Or you can also just use F equals to ma. But remember to put the square bracket because we want to find the dimension for F. Right, so you need to solve this question also. And the next one is work done. So what is work done? Work done, the formula to find work done is force time distance or force time displacement. So I'm just going to write this as displacement, which is S. Force time displacement. Okay, so solve this. And also power. The equation to find power is P equals to, so you need to put the square bracket here. So power is equals to work over time. Okay, so solve these 4 questions and submit on Google Classroom later.